Welcome to the 19th lecture of course Polymer Science and Technology. In today's lecture, we will see the molecular weight control in step polymerization. We will see the qualitative and quantitative method both in this class. So, the first method is to quench the reaction, means to reduce the temperature of the reacting mass. By reducing the temperature of the reacting mass, the polymerization reaction or any reaction will be stopped if it is an endothermic reaction. Okay, so by and in case it is exothermic, even though by reducing the temperature with the help of flow of the coolant inside the reactant, when the temperature will be such a low that the activation energy requirement is more than the present energy of the system, then reaction will stop according to the thermodynamics. So, to stop any reaction or in particular step polymerization reaction, we can quench the reacting mass. Second method is to use excess of one functional group. We can have a slight we can take the two reactant diacid and diol in slight excess with another one, means one of the monomer will be in slight excess, and as a third option we can add monofunctional compound to the polymerization reaction so that it may stop the polymerization reaction. So let's see the second case, because in quenching method you have to just reduce the temperature of your polymerization system. So in second case we will see excess of one functional group or excess of one monomer, because functional group is related to the monomer, so you have to basically take excess of one monomer. Here we are in this case of polyester, we are considering that diacid, this is a diacid, one functional group, this is a second functional group, so this is a diacid. So diacid is in slight excess, not in very huge excess, it's slight excess. Mean if it is diamine is 1, so diacid is 1.01 or 1.02, like that. So in case of okay, this is a case of diacid reacting with diamine, so this is going to form amide, NHCO. NHCO is the amide, and when amides groups are present in a polymer, so this kind of polymers are known as polyamides. And nylons particularly, you are aware that polyamides are basically nylons. Nylons is a trade name by the DuPont company. Okay, so technical name is the polyamide, and polyamide will be formed by the reaction of diacid and diamine. Here in this case diacid in the slight excess. So what will happen when diacid will react with the diamine? Then we will have, after some time we will have same functional group on the either end. Here this is also carboxylic group, and here it is also carboxylic group, and since diacid in excess, so now this polymer chain cannot further react because the monomer in excess is the diacid, so carboxylic group cannot react with another carboxylic group. Carboxylic group of course can react with the amine group, but diamine is in less quantity and diacid in excess quantity. So because of that imbalance in their ratio, after some time increase in the molecular weight will be stopped and polymerization reaction will be stopped. So this is the one case. The third case is the addition of monofunctional compound. I hope you all remember the monofunctional compounds means where the functionality of the compound is one. In other words, or simpler words, we can say we can use a compound having only one functional group. For example, here in the same example, these are diacid, this is the diamine, and we are taking a monofunctional compound, benzoic acid. Benzoic acid is also having one carboxylic group. So this carboxylic group and this carboxylic group is same. So what will happen when diacid will react with the diamine and it will form the polymer? After some time the concentration of the diamine will decrease, and on the either end of my growing polymer chain we will have the carboxylic group, and inside the reacting mass diacids are available and less number of diamines are available. So the growth of polymer chain will be stopped. Okay. So these are the three methods how we can manage the molecular weight of the polymer. Now we'll see the quantitative aspect of molecular weight control. So we are taking the first case where AA and BB type of monomer with slight excess of BB type of monomer. So what is this case? This case means AA means a difunctional or bifunctional monomer 1 is going to react with another bifunctional monomer BB with the slight excess of BB type bifunctional monomer. You can say particularly this is the diacid which is reacting with diol or diamine with slight excess of diamine or diol. Okay. So in this case the number average degree of polymerization will be equal to 1 plus R over 1 plus R minus 2 Rp. This is the formula given where R is the ratio of Na over Nb and P is the conversion that you know. Now what is Na and what is Nb? Na and Nb are the number of A and B type functional groups. Okay. For example, in case of a diacid, COOH dash R dash COOH. This is a generalized formula or structure of a diacid. So one diacid molecule basically contains two carboxylic functional group. So the number of carboxylic group per molecule of diacid are 2. So 2 carboxylic group. Okay. Similarly, in case of diol or diamine, there will be 2 amine group or 2 hydroxyl group per molecule of diol or diamine. Correct. So here there is a formula given. Using this formula you can calculate the number average degree of polymerization, and you also know how to convert number average degree of polymerization into number average molecular weight of polymer. You have to just multiply xn bar with the repeating unit molecular weight, correct, to get the number average degree molecular weight, number average molecular weight. Okay. The second case is AA and BB type monomer with a monofunctional compound B type. That's mean a diamine AA and a diacid BB are going to react to form a polyamide with a monofunctional compound of B type. B type means benzoic acid, as in this case. Here diacid, diamine and benzoic acid. So the functional group attached to the benzoic acid COH is same as the functional group present in diacid. So in this case you can see the BB type is diacid, and B type monofunctional compound you can consider benzoic acid or any other low molecular weight acid. So in this case also my formula for Xn bar is same, 1 plus R over 1 plus R minus 2 Rp, where R is equal to Na over Nb plus 2 Nb dash. Na, you know, the number of A type functional group, and Nb is the number of B type functional group, and Nb dash means the number of functional group provided by the monofunctional compound of B type. That means this B type number of B type functional groups are coming from the monomer, and here Nb dash is the number of functional group coming from the monofunctional compound. Okay, so the formula of Xn bar is same, just the formula of ratio R is different. And you know, the Xn bar is equal to number average molecular weight divided by structural unit weight or repeating unit weight. Okay, in case of step polymerization reaction, there is slight difference in SUW and RUW. SUW is structural unit weight and RUW is the repeating unit weight. What is that difference? In case of AA and BB type of reactant, your structural unit weight is half of the repeating unit weight. And in case of AB type reactant, here you will say, what is this type of reactant? AB type of reactant. AB type of reactant means a reactant which is having two different functional group in the same molecule. Okay, means a molecule containing one diacid molecule and one diamine molecule. Okay, there are not two different monomers, but the same monomer will contain two different functional groups. Okay, so in this type of reactant, my structural unit weight is exactly equal to repeating unit weight. And case 3 is the AB type of reactant with B type of monofunctional compound. Again, the formula for Xn bar is same, 1 plus R over 1 plus R minus 2 Rp, and R is Na over Na plus 2 Nb dash. Okay, in previous formula here R was Na over Nb plus 2 Nb dash. In this case it is Na over Na plus 2 Nb dash, and in this case structural unit weight is exactly equal to repeating unit weight. Okay, now here are some example. For example, nylon 6. Nylon 6 is an example of AB type of monomer. An example is the caprolactam. Caprolactam is the monomer that contains the amine group as well as carboxyl group. Okay, so this is the formula of repeating unit for nylon 6. Here you can see the polyamide group NHCO. NHCO is present in this formula. So this is the polyamide and termed as nylon 6. So the structural unit weight, if you calculate the molecular weight of this repeating unit, is exactly equal to repeating unit weight, which is 113. Now see the example of nylon 6,6, which is an example of AA and BB type of monomer. You can polymerize nylon 6,6 using adipic acid and hexamethylene diamine. So hexamethylene diamine is also a diamine containing two amine group, and adipic acid is a diacid containing two carboxylic acid. Okay, so when these two monomer will polymerize, they will form nylon 6,6, and the functional group you can see NHCO or NHCO. So these are the amide functional group present in the polymer. That's why this polymer is known as polyamide. And the repeating unit weight, if you calculate the repeating unit weight of this entire unit, is 226. But the structural unit weight is half of the repeating unit weight here in this type, AA and BB type of reactant. So your structural unit weight is half of the repeating unit weight. So you can calculate the structural unit weight as half of the repeating unit weight. So what is the point you should keep in mind? You should know which type of polymer or which particular polymer is going to be polymerized, which type of monomers. Okay, when I ask you nylon 6, you should understand this is a polymerized with the AB type of monomer known as caprolactam. If I ask you nylon 6,6, that means it should come to your mind that this is a product which is formed by AA and BB type of reactant known as adipic acid and hexamethylene diamine. If you will not remember this, then you cannot calculate the structural unit weight. Okay, so in order to guess or calculate the structural unit weight, you have to memorize which polymer is going to be polymerized by either AA or BB type monomer or AB type monomer. Similarly, polycarbonate, this is the repeating unit for the polycarbonate, and again this is AA and BB type of monomer, where structural unit weight is half of the repeating unit weight. In case of polyethylene terephthalate known as PET, again this is an example of AA and BB type of monomer. So the structural unit weight 96 is half of the repeating unit weight 192. Similarly, nylon 6,10 is polymerized with sebacic acid and hexamethylene diamine. So this is AA and BB type of monomer. In this case also the structural unit weight 141 is half of the repeating unit weight 282. Similarly, polybutylene terephthalate PBT is also AA and BB type monomer produced by AA and BB type monomer, and here also the structural unit weight 103 is half of the repeating unit weight 206. So this is the end of lecture 19. I hope you have understood and enjoyed this lecture. Thank you very much for your patient hearing.